In this particular first session, just to set the stage, I will do a little bit more talking than I would like to. I also want to thank Manish and Amay for working with me to make sure that we could put this all together, and hopefully we'll have a great session. To get started, I just want to spend a minute talking about ACADS. When we started off with ACADS, our whole idea was that as the workforce is getting reshaped with evolving technology and the emergence of AI and automation, etc., there's a constant need for us to be able to acquire new skills. And we wanted to position ACADS to enable all of you to be able to learn new topics as quickly and as effectively as possible. So for us, the real success, the real metric that we use to measure what we are doing is to make sure that each one of you is successful, right? So we are absolutely committed to you. So please make sure that you take full advantage of it. The one important ingredient that I wanted to share with you is a simple blueprint for what can make all of you successful. And in order for us to be successful in any learning experience, I cannot overstate the importance of motivation and focus. And these are two things that is very hard for an instructor to create. So if all of you can find your motivation, and if all of you can stay focused, then I think that will be a solid foundation for all of you to be successful. Once you have the motivation and focus, I think the next essential ingredient is a good process. And at least in my own learning experiences, I've found good process is hard to come by. And by process, I mean here the classroom that we are in today, the exercises that we do, the way we absorb information, all of this is part of this process. What do we do when we get stuck on a topic that we cannot break through easily? All of this is part of a good process. And I will put all my energy. I've already spent a lot of time and delivered many courses trying to make sure that everything we discuss in this class is part of a good process. Once we have this good process, and you will tell me, and I'm looking for feedback on this process from all of you. And then once we have a good process, the next essential ingredient is plenty of practice. And so again, I will stress this a lot. Practice, especially good practice when you are concentrated and focused on what you're doing, will make a world of difference. And I've worked with different students. I know that life happens and we will get pulled in many directions, but making sure that there is a solid core of a few hours a week where we can actually practice would be fantastic. And then the last ingredient, I think, is that we need feedback on the work we are doing, on the practice we're doing, and the process we're following. And so in terms of feedback, we will have some feedback for you immediately from the quizzes and the projects you do. I just want to stress again, I do not see the quizzes as anything more than a chance for you to do concentrated practice. Okay, so don't be intimidated if any question is hard. The answer is not important. The process of finding the answer is important. So good feedback will be always present. If there's anything you want to discuss, then of course, send us an email. There's also discussion boards where you can post your questions. And so all these ingredients, I hope, will lead to a good, successful learning experience for all of you. And if I like to say this quickly, that if you're focused and motivated, you put in quality practice time, then you will be successful. I have tried to make this course in such a way that everything that I would use during the session is actually on the website, right? So just for the first few minutes, I used an extra PowerPoint, but otherwise I will make sure that all the materials that I discuss in the class are on the website. So if all of you can make sure that you're logged into the website, and I will, in all the sessions, excuse me, in all the sessions, I will make sure that everything we use, in fact, I've even embedded the code editors and everything into the website. So hopefully it should be a one-stop shop. So when I created this course, we created a session 0. When I looked at the website, I saw that not many of you had the time to go in and explore this session 0. So we will kind of walk through this today. So if you go into the session 0, this was meant to be a little bit of background for all of you to do before we started the session. But now that we are here, we might as well just, let me just quickly walk you through it. Now, the way the website is architected, every time you click on a session link like that, it's going to pull down a little bit of information, data. So there could be a small bit of lag on the website, no more than a few seconds. But if you experience this lag, just be patient, it will show up. But once it shows up, all the tabs on the website will be already loaded up for you. Okay, so and then you can just click through these tabs. Now, please make sure that when you're on a particular section, you do look at all of the tabs, okay? Because sometimes it picks the last tab or the first tab and you may miss some information, okay? Okay, so if you went into the session 0, there are a few things here that I want to draw your attention to. So here I will walk through this in all of the tabs. There is a pre-course survey that I would like all of you to take. And in that survey, I am attempting to understand what your goals are. I'm attempting to understand what your previous programming background is, etc. So if you take this survey, then next time I will tabulate the results of the survey and then we can discuss it together. Okay. Then there is a discussion forum. So if you can go on the discussion forum and post some information about yourself, maybe we can get a conversation going. And please take a look at the course syllabus. The syllabus is posted up here on this section here. So please make sure you just glance at it. It will give you a good orientation. If there's any topics that you want to have a discussion about, don't hesitate to reach out to me. And then I put in a small section about what a computer might be, just a sketchy model of a computer. So if you want to spend some time, please make sure that you click through session 0. Okay. So here's the discussion forum. You can just click on add a post and just add post. Okay. And here is the pre-course survey. So if you click on this link, it will take you to the survey and you can just fill it out. So it will be really cool if all of you can take that survey today. So then tonight I will just start tabulating the results and we'll be ready for next time. Yeah, and of course I've asked this question here, so maybe we can discuss together why we want to learn Python. Just quickly, if any of you have any issues with, has any of you had any issues with the website, with access? Has there been any problems or everyone's okay? If anyone has any issues, don't hesitate to reach us. You can send an email to support@acats.org, and also you can text.
And also they can chat. You can chat here. And also if anyone is having any problem with the audio, I know that, Praveen, one person is having problem with the audio. I just ask talking to him. But I hope everyone else is all set. And make sure that you can log into the site. That's very important because as Vijay mentioned, we will be spending all the time during the lecture working interactively on the site.
Yes, yes. Okay, so like I said, again, today, we will already start writing some code today. Okay, so I'm sorry, I apologize. I struggled a lot with how much I need to say up front, but I guess the first session is one where I got to set up a few things, make sure that we are thinking along the same lines. But I promise you that the second half of this conversation today will be about writing a little bit of code. And then from next time, we will have less talking and much more code and actual writing of code. Okay, so so let's start with one of the important concepts that I would like to emphasize to all of you, which is that when I think of writing code or programming, very often we think of code and programming as a way in which we communicate to the computer. But I would like to pivot that definition and say, actually, code is a structured form of thinking. Just as writing in a particular language like English or French is a structured form of expression and communication, code is also a structured form of expression. And if that structure is done just right, then computers can also understand and execute it. So as we go through this course, I want to draw your attention always when you're writing a piece of code to say, is my thinking clear? Is my thinking clearly expressed? And how well is this thinking understandable to another human being first? Then we will ask the question, is this code error-free vis-a-vis a computer? And will a computer then understand? Okay, and that will make a tremendous difference. And of course, you can see as soon as I said this, I'm faced with the challenge, we are all faced with the challenge of becoming better thinkers. And so maybe that is one of the biggest excitements of learning to program, is that now we have a very structured task at hand that forces us to think better, right? And we'll see some examples today. They may be toy examples, and we have a big, interesting challenge. I myself, as I learned, okay, I trained as a mathematician and a physicist, which was also structured forms of thinking. But when I came to computer science and programming, I was encountering other challenges of, for example, how do I take a big problem and break it into smaller chunks? When I'm solving a problem, I could write a big 10-page of code and it would solve the problem, but then it would be very hard for people to understand it, for me to remember it, for me to maintain it, etc. Right? And so the computer programming experiment will give us a lot of feedback into how we are thinking. Okay, and then of course in this course I want to make sure that we solve some interesting problems. Our goal here is to create for you a programming foundation that will be easy for all of you to pick up, projects in data science or machine learning, or even writing applications, etc. And so that will probably lead us to this question. Okay, there are so many books, there are so many courses, why another Python course? So let me take a couple of minutes and just talk about some of the things that I have tried to make special for all of you. So when you see them, please come back to me with your feedback. I think the hardest thing for us to get when we're trying to learn something is what are all the important concepts. And there's emphasis on concepts. So this will be very interesting as we go along. You will see that there is a programming language. There is a lot of things to do with respect to syntax. What is a variable? What is a type? Even today, we will see those definitions. But then there is an abstract conceptual idea behind those artifacts that we have in programming. And I will try to draw your attention to these concepts. Okay. And if you are facing any challenge, I want always for you to be able to ask the question, am I having a conceptual problem or am I having a syntactical problem? Okay. And we need to control both of them. Of course, right now my words don't illustrate this. It's not very interactive yet because I'm just trying to get a lot of information to you quickly. But we will write code as we go along. I already talked about structured thinking. So let me spend a minute just talking about this topic, which happens to be a rather big topic, which is computational thinking. Okay, and the idea here is that in the last, if you want to say 50 years of working with computers, we have started to appreciate that working with computers requires emphasis on a different skill set than, say, for example, mathematics. So in mathematics, you would ask the question, can I solve a problem? If you solve a problem, you're done. But if you're a computer scientist, you would ask the question, is that solution efficient? How long does it take for that solution to actually execute? These are not mathematical questions. These are computational thinking questions. Another kind of natural question that a computer scientist will ask is, if I solve a problem, is this solution like a one-off or is there an algorithm here? And an algorithm is a reusable idea, right? And so there's much to be spent on. And also this idea, for example, of abstraction. We will see this as we go along, but I just want to say, looking at a situation and saying, what are the abstract elements that define this situation is not a question that we ask except outside of abstract mathematics, for example. So there are a lot of ingredients that go. I don't want to give a long talk about what computational thinking is, but maybe I want to plant the seed, the conceptual seed in your mind that says, in what sense is working with computers and writing programs a different mode of thinking than mathematics or even just writing an essay? Okay, and answering that question in some detail will be helpful. The other thing is we want this course to be data driven, so I will constantly keep asking for feedback and input from all of you, and I have used all the input that I've got from my students in the past, and I view every interaction of ours as a way for us to understand better what challenges students face. In creating this material as well, every time I sit down to write up something, I try to ask the question, what could hold a student back or a learner back from mastering this particular topic? So the data is extremely important. And of course, one last ingredient I have tried not to make this course targeted at the ideal student, which would make my life very easy. But I've tried to say, students come with various backgrounds, with various experiences, and I want to make all of this material accessible to each and every one of you. Okay, so rather than keeping it into a narrow focus and targeting an ideal student, I've tried to incorporate different backgrounds. With that said, welcome to the course. I would urge all of you to just read this page. I don't want to go through this page in great detail. I've tried to put a few nuggets of my own thoughts of how you can be successful in this course. I would say that the biggest ingredient is this great 1.5 hour window that we have together. I know life happens. There are many pressures and distractions, but if you can come energized and ready to absorb material in this 1.5 hours, I will try to make sure that you get maximum benefit out of it. And then ask questions in the forum, send me email, don't hesitate. I think formulating questions and asking them is a very important skill. And then the last ingredient I mentioned already, your study times, right? So if you can spend, I would expect, if you can spend between 1 and 3 hours a week outside of this session, that would be fantastic. If you can do more, then you can go further, okay? So now one last question, and then we can start doing actual Python. So I guess we should, before we start doing Python, we have to ask the question, why do I want to learn Python, right? Why learn Python? Some of you have learned other languages. When I get your survey responses, I'll be able to tell exactly how many of you have learned what languages. But today, I want to say that, first of all, the reason we have many languages is because all of them emphasize different paradigms, different programming paradigms. And I won't be able to get into programming paradigms. I myself am a language geek. I think Ame is a language geek too. He learns a lot of different languages. And it's very interesting to ask the question that when people design languages, they keep certain programming paradigms in mind. And then we have to ask the question, does this particular programming paradigm make programmers who are trying to solve a certain class of problems more effective or not? Okay, so it's a deeper discussion. And of course, like most of these discussions, there is no one answer. There is no one perfect language. So eventually I would recommend all of you to learn a few more languages, but for today, your plate can be pretty full just learning Python. Okay, so what is the sweet spot in which, Python has become one of the top 3 most popular languages is that Python happens to be a language which is called a dynamic language. And a dynamic language is one in which, and we'll talk about types in a second, but I will just make one sentence. A dynamic language is one in which, even though types are present in the language, there are many places in which you can pretend that you're not type aware. Okay, and we'll discuss this in detail. So that makes your code look a little cleaner, a little bit more like English. And Python was also created not to use semicolons and curly braces and so on. And it uses white space in a clever way. So in general, Python is a little bit easier on the eyes. There are other languages also designed to be easier on the eyes, but this is definitely one of the characteristics of Python. And the second idea in Python is that it's an interpreted language. If you look in session 0, I've talked about how does a Python program run. So that might help you fill in this picture. But the code that you write in Python is converted into an intermediate language, and then it's executed at runtime, right? And this idea led to the point that Python programs can be built incrementally. So you launch a Python session, you start typing, and the Python program can grow continuously. Compared to a language like C, for example, where you build the language and you run the whole program. You want to change it, you have to change the whole program, right? And this paradigm, I want to stress, is very important for us who want to interact with our code continuously and evolve it. Now, if you're doing a hard programming task, you might argue, why do I need to do this? But if you're a data scientist, you've got a lot of data and you want to load it into a program, you don't know what program you're going to write, but you want to interrogate the data and change your question continuously, right? You ask a question, you get some information, then you change your question. So that's a natural interactive programming cycle. And that is a sweet spot for Python. what do we give up in order to get this is a little bit of performance or a lot of performance. Okay, so if you're performance hungry, Python is not the sweet spot. But if you want to be interactive, Python hits a very nice sweet spot. And that sweet spot has been recognized, and therefore Python has simply grown explosively. And for those of you who are interested in those kinds of topics where interactive programming, exploratory programming is the task at hand, then Python will hit that sweet spot. Okay, and then the last ingredient here with Python is that there's a vast array of libraries. And by the time we get to session 4, I will start pulling out some of these libraries. And these libraries encode millions of lines of code that can do all kinds of amazing things. And so part of our skill will then evolve to understanding these libraries and using these libraries to solve the problems that we have at hand. Okay, so with all of that said, so there's a lot to be done in terms of interactive programming, mathematics, AI, data science, etc., that we can explore with Python. Okay, so much for the theory. I hope I've convinced you that Python is a good investment. But more than all the meta stuff about all the things that you can do with Python, I just think that you will find it a fun and easy to use language. Okay, so for today, I wanted to introduce a few programming concepts. So let's start off, I guess, with the easiest idea that Python has built into it a calculator, right? And a calculator is a great place to demonstrate Python's interactive capabilities. Okay, so finally I've come to a place where we can do some interactions. So let me just, I hope all of you are on this section 1.2.2, which is on the screen. And I hope all of you can see it, and the fonts are big enough for you to see. What we're using here is an embedded Python program, right? So the Python program in this case is actually running inside your browser, okay? And this program is executable immediately from here. So first things first, I guess I will walk through all this, whatever is on the screen here. First things first, just a quick tour of what you need to do here. Are all of you able to hit this run button? If anybody has any problem, can you just chat, okay? But let me just talk to you now about some features of this thing. So what you see here is what is called a code editor, right? It's embedded now in a browser. And the reason I took an embedded editor for the first couple of sessions is that we don't have to worry about installing anything or dealing with different environments on your computers, etc. So when you come in to do your work for the first few weeks, you can just go straight away and start writing your code, okay? Now, the only thing that you need to know here right now is that there's a run button, and it will execute all of the code that's in this window. And for the first couple of sessions, I will just work with just a single file, okay? So to get started, what is the easiest thing we want to do is to recognize that Python has a calculator in it, right? And the only difference is that when you look at the typical calculator operations, there are a couple of operations that have different symbols than you would expect, right? So multiplication is represented by a star, and division is represented by a slash. And then the exponentiation is represented by a double star. Okay, addition and subtraction have the same symbols. So if you look at this code here, you can see I have used one, okay, so there's a little bit of a bootstrapping problem here. I did not want to use functions, but to display something on the screen, I thought I might sneak in the print function, okay? So for right now, let's just use this idea that the print function, we'll talk about functions in detail at some point, but for right now, you can say that if you type the command print and you put parentheses, and inside the parentheses, you put stuff. So right now, it's just a calculation, right? It's a sequence of numbers and operations. Then it will get displayed on the screen. Hopefully that's easy enough. Again, if there's any questions here, I am glancing at chat. It's hard for me to say if everyone's okay, type yes, and I'll get 35 yeses. But if anyone's having any trouble here, please chat. Okay, so I think if you've run this, you've run your first Python program. Of course, now let me just do one thing that I guess every programming class would do. It's the Hello World program. And Python programmers take great joy in doing the Hello World program like this, right? And so I have to just tell you one more thing. You see the single quote that I've used to surround the word hello. So that makes a string in Python. And again, we'll cover strings in gory detail. But for just now, if you ever wanted a string which can be used to display information on the screen, you surround it with single quotes. Okay, and then we can have it displayed. So if you run this now, it will print hello. And if you've written a program like Java where you have to, create a class and put a method on it and make it a static method and so on, it gets more complex. The Python Hello World program is just one line, right? So there are some languages in which Hello World is easy, but we cannot declare victory on programming just because Hello World is easy. Okay. So what have we learned right now? We have learned the print command, and we have learned how to do simple mathematical operations. Okay. And you have learned how to use the Trinket IDE. Okay. So now just so now here's an example of where language and syntax becomes important to us. So one small thing that I want to talk about is the notion of an identifier. Okay. And an identifier is just a label. Okay. And the idea is that you can take an identifier, and it can be any label that you choose, and you can assign different kinds of things to it. And how do you do assignment in Python? You do assignment with an equal to symbol. So now a moment of attention. The equal to symbol in programming is confusing because nothing is equal to there. Actually, the equal to means that I'm going to assign a value. So if you look at this code on line 3 here, the label or the identifier trillion is assigned a value of 10 to the power of 12. Okay. And even though it says equal to, you should read it as assigned to. Now there are languages like R that go out of the way to try to have a different type of symbol for the assignment. But even in R today, you can actually use the equal to, right? So some people think it's overkill to have a different symbol for assignment versus equality. Okay. So we will use this. Initially this can't trip you up, but I think it's really important. And now the important thing that we are doing here is you take an identifier, and if you give it a number or a simple mathematical expression that involves numbers or operators, we can call it a variable. Now again, the name variable is slightly confusing. Why? Because once I have set trillion to 10 power 12, it does not change. So in what sense is it a variable, right? But I guess the sense in which it is a variable is you could come back tomorrow and change it to 10 power 9 and it would change. Okay. But this variability of a variable, later we will discuss in gory detail, the mutability, the change of a variable is a very important ingredient in your programs. And when things change, your programs behave differently. So managing that change becomes a very important conceptual programming task. Okay, I said a lot of things. For those who are slightly more advanced programmers, you will appreciate those comments. For others, it doesn't matter. Just be aware that a variable is constructed in this way, right? There's a label, there's an equal to sign, and then some value on the right-hand side, okay? Most of it, using a variable should be easy, but I just want to put a couple of constraints on you, which Python does. The first constraint is that a variable can have any kind of characters in it. In fact, today Python even supports emojis, but I don't think we want variables with emojis because we cannot speak them out easily. But one constraint for sure, you cannot start your variable with a number. Okay, so that's one constraint. And then the other one is that there are a bunch of keywords that I've listed for you here. These keywords cannot be used as variable names. Okay, and the reason is that every language reserves a few keywords that it can use with a special connotations inside the language. And so they don't want you to take it and assign variables to it. Use it as a variable, okay? So with these few couple of constraints, you can pretty much make any kind of variable name you want, okay? I thought about whether I want to introduce you to this intricacy, but I guess it's okay to spend a second. Okay, so then let's just do a quick poll. Can all of you tell me, based on what I just said, if you hadn't fallen asleep or I wasn't talking too much, can you choose what's the invalid identifier? And you can do the other one too. I'll give you like 10 seconds.
I'll just make one comment. Like the session one seems very simple, but the course get built into complexity very fast. So it's very important to pay attention. Like by the middle of like session two, you will see that it gets really, really advanced. So
yes, I think Manish highlights a point I want to tell all of you. My classes tend to be deceptive in the sense that there could be moments when I'm just working on concepts and ideas and language, and then we will accelerate, right? Because I assume that I built a foundation that I can accelerate on. So of course, let me know if you find things easy. I can give you other stuff to work on as well, right? If you've worked in previous classes on Python or other programming languages, some of this can be easy. I still try to give you some nuggets of wisdom, but as Manish said, we will accelerate. Okay. Okay, so some of you fell for the trap, I guess. You can just see. Okay, so it's very innocent looking thing, right? Class, but class is actually a reserved word, right? So, okay, I set some kind of trap there, but okay. So now let me spend another minute here. Like I said, some of these are coming from a programmer's toolkit. So just think about this idea. For example, now that we have labels, we can choose any kind of name we want for labels, but that could make the labels look rather messy. And so we use what are called conventions. And I want to tell you something very important here. I will stress this a couple of times as we go through today. Choosing the name, choosing the variable is not easy. When you have to write big programs and you need lots of variables, it seems like an easy thing. And I do not recommend calling all your variables X, Y, Z, N, A, B, Q, etc., right? Because they don't convey much information. There are special situations where N and I and so on can be used, and I'll highlight them. So we have to choose good names. Hopefully those names will explain to us what things are going on. But now there's interesting conventions. So the first convention that we use for names is called as, what's the problem? The point is that to make a variable, we will use multiple words sometimes. Name of person, that's 3 words. And you cannot leave spaces in variables in Python, right? They have to all be joined together. So if we put the words together, then how do we know what's the boundary between 2 words? You do something special on the boundary. And whatever you do at that boundary between 2 words becomes a convention. So the first convention is called snake case convention. And I guess if you squint, you can see there's an underscore between the words, and it looks like a snake making some kind of wavy path, right? So we call it snake case convention. I put this on top because this is the default convention in Python. Okay, different communities have different conventions. In Python for variables, that's very common convention. Okay. The next one, just for interest, is also a natural looking one. Languages like C# and even sometimes Java use this convention more. This is called the camel case. It's like the humps of a camel, I guess, where we use capital letters to separate words, right? So every time, except for the first word, every time you come to a word boundary, you use a capital letter, okay? And then the last one is for people who don't like to use underscores. They use dashes between words, and that's called kebab case. Obviously, you can figure why that was. But again, you can see now, apart from the syntax, there's a lot of scaffolding and a lot of thought going into even how do I choose the name of a variable, and then how do I actually type it, okay? And from day one, if you get that into your thought process, you'll get better and better at choosing your variables, etc. Okay, so now we've got identifiers, we've got variables. So now the important question. So this is a good chunk of today is this, right? So now the idea is as soon as we can get a computing skill, we can ask questions. And I urge all of you to think about interesting questions. So I try to come up with a few questions. You can tell me later if they're interesting or not. So the first question we have to solve today is, how long will it take for you to spend $1 billion? Okay, and you can see that you can ask this question. So can we take a poll? Maybe all of you can take this poll. How long will it take you to spend $1 billion? Do you want to take a poll and see? Manish, can you just refresh and let me know if you can read out the results once you got it? How many responses do we have, Manish? Manish is on mute.
$26 right now.
Okay, so I guess I should put it on screen so everyone can see it. You want to read out the stats, Manish?
Give me a second.
So, yeah.
Yeah, so I think 54% said more than 10 years, 21% said less than 10 years.
Okay.
Exactly 123 years, 11%. 1 day, 7% think they can spend 1 year.
Okay, so I guess it shows us the different strategies that you guys use to solve problems, right? You should just stare at it and try to understand why those particular numbers were chosen, okay? But okay, so now let's dive into why I put this thing here. Clearly, it's a mildly interesting question. Of course, you can see my problem at this moment is I don't want to make my questions too difficult, because if they are very difficult, then it's hard for us to make progress. But immediately once we ask such a question, we have to come up with some strategy to solve it. And the strategy to solve this question is to say, okay, if I spend $1 billion in 1 second, then it can be 1 second also, right? So I have to make some assumption. The obvious assumption, easy assumption is there should be some rate at which I spend. So why not I assume that I spend $1 every second? Okay, and you can tweak this number later. So the idea with getting started to answer these kind of questions is don't spend too much time trying to find exactly the right rate to use, right? You can start by saying I'll spend $1 a second, and later you can change it to $10 a second, right? But then you start to get a feeling for what the answer does, okay? So we can now use Python to solve this problem, okay? So let me just show you what I have done here. All of you should be able to run this code and it should produce the answer for us. So we create some variables, okay? So first of all, it's nice to break your calculation into small steps. The first step here is this variable amount to spend. You can see I use the snake case convention and I said it's 1 billion. Okay, by the way, using the exponential notation is probably a nice way for us to represent large numbers. Initially, if you're not using exponentials a lot, it may seem like a little bit different, but to think of a million as 10 power 6 and a billion as 10 power 9, once you get used to this, it will be very easy for you to recognize a number rather than counting all the zeros and so on. Okay. Okay. So now we have to ask the question, how much do I spend in a second? And I made it a variable because I put $1 a second, but I can change it to $10 if I wanted to change it to $10, right? Then immediately the next question I could ask, and there are a couple of different, once you make these assumptions, there are many different ways to solve this problem. I took one particular path which said, let me see how many seconds are there in an hour. So that's 60 seconds in a minute, 60 minutes in an hour. And then the amount I spend every second, I multiply these three and I get the amount I spend in an hour, right? And then I was interested to know how much I would spend in a day. So if I multiply that by 24, then I get the amount that I spend in a day. And when you actually run this code, you'll see that's about $80,000. Okay, so that's a pretty large number. It gives us a feeling for how long a day really is. It's a lot of seconds at least. And then the next step is to say, okay, if I know how much I could spend in a day, then I could figure out how much I can spend in a year. So I multiply by 365. Now you see that you could have done all this in one multiplication. right? You could have done 60 times 60 times 24 times 365, but then it doesn't give you any of the intermediate answers. So there is skill in writing this program, and the program is dependent on how you want to think, what intermediate values you want to see, etc. But this program illustrates how we can use variables to break our problem down into small steps, and we can inspect the outcome at every step, right? So you can build this, think of writing this program incrementally, okay? And then finally, you can just print out, you have the total amount you have to spend, and you just divide by how much you spend in a year, and it'll give you the answer in years. And if you run this, you will get the answer for this. So it's about, if you look here, it's the last thing I printed out, it's 31 years. Okay, so for those who guessed right, guessed wrong, guessing is always a good thing. I encourage all of you to guess, because that's a different type of a skill. Picking a good guess is a good skill, but we should, of course, immediately back it up with a computation, right? And then be able to do those computations quickly. Now, immediately I would leave you the task. Hopefully some of you were typing this during the session. Delete this whole thing and write it in your own style. Okay, solve this problem again. It's a good, simple 5-minute practice thing. Okay, but the faster you can go from a question to an answer, the better we're going to be. And today we're going to spend a little bit more time on this kind of questions. Okay. Okay. So this is a good question. Again, as I said before, well, you will tell me if it's good or not. If I decided to walk across the United States, how long would it take me to walk across the United States? Okay, I don't think I created a poll for this one. I should have. Some of you can put it in chat. What do you think? Okay, I'll give it a second and watch chat. Does anyone want to guess how long it would take? Four weeks? It hurts just thinking about it. That's a good one. Okay, so I am going to tell you that there are actually people who, cool, I love all these guesses. Okay, I'll make this into a poll next time so I can tabulate the answers. But I see a little bit of a spread here. I like 480 hours. I'm curious where that number came from. Okay, so you guys can keep engaging on chat, but I will start to build up the solution, okay? So the solution is fairly easy. Again, I don't want to spend too much time on typing stuff. I want you guys to type it. Today, I'm just giving you, because it's the first class, I'm just giving you solutions. I'm showing you how things are done. But of course, next class, maybe one of you can volunteer to write these solutions. Okay, and we can just observe as one of you write these solutions. So,
yeah, sorry, I'll interrupt. Normally, we run the classroom with one student volunteering to write the code. So be prepared to write the code during the classroom. Don't be afraid.
Yeah. I would ask this question. You guys are okay to volunteer to write the code, right?
But also, it will be better if you can share your cameras from next time. Be prepared for that, because that gives us like a good understanding of the engagement during the classroom. Thank you.
Yeah. Well, it's certainly motivating for me to see your smiling faces. And also I can get some feedback immediately from you. Okay, so there are many ways to solve this problem. So I'm giving you one way to solve this problem. I guess many of us could have flown across the country. So I used flight as a model to solve this problem, right? So by the way, at this moment, I guess some of you could have said we can ask Google, right? We could have Googled. It's become a thing. For these questions, I guess you could Google and you could find answers. And I think Googling is a skill that all of you should develop. But I think the skill of also thinking about the problem, we want to build up a little bit here. Okay, so I don't want to forbid Googling or anything, but I want to show you for sure that every time we solve a problem like this, we will be enriched, because we will exercise our thought processes in a particular specific way, and it is a very rewarding thing for us when we do this. So I used flight as a model, but one of my students actually had done a bus trip, and they had done a bus trip going south. So they kind of used the bus trip time and the speed of the bus, and then converted from going south to going west, and so on, and was able to also achieve a sensible answer, right? So there are many answers. Every time we answer a question like this, you're building up a model, and then using that model to find your way to the answer, okay? So one simple model here could be, I will try to ask the question, how long does it take to fly across the US? And it takes about 6 hours to fly across the US. Again, like I told you before, it is interesting to debate how big this number should be. Should it be 6? Should it be 10? But we certainly know it's not 24 hours. So we can easily bound it. And it's not 1 hour. I wish we had such fast flights. So it's easy to come up with a reasonable starting guess, right? So when I started doing this kind of problems when I was younger, I would not make it past the first step. Because I'll be like, how do I know how many hours is a flight? I don't know. Should it be 6? Should it be 10? I would spend too much time on getting started and I would never finish. What I'm trying to show you is once you have a model, you can get it started with a reasonable starting point. And if that starting point was not reasonable, as you work through it, you will refine it. Okay, so don't hesitate to make your first building block on a reasonable basis and continue to work on that basis. Okay, so if it's about 6 hours, then the next thing I need to know is what's the speed of a plane and what speed does a plane fly? Again, you have the same question, and Google is always there, so you can always Google and check. But we should ask the question, what's a reasonable speed for a plane? Right? And we know that a car can go 100, 120, 150, depends how fast you drive, but about 100 miles per hour is easily reachable by car. And a plane is obviously much faster than a car. So you could have gone for 1,000 miles per hour, but 500 is a reasonable step. Okay, again, I'm only arguing for reasonability, right? I think 5,000 would be too high. 50,000 would be way high. That's like rocket speeds. So it's easy for us to get started, right? Again, we got 6 hours and 5. And you can see the problem falls apart as soon as we made these two reasonable assumptions. Because now the next thing I have to do is to say, okay, therefore, how much distance is it? And I got an estimate for the width of the United States. Now I encourage all of you to use something similar for your own favorite country, either the one you live in or the one you intend to visit. But immediately that gives us a sense of the dimensions of a country, a sense that is not just the same as looking at a number, right? Which is because you have created this yourself. And it's also interesting to imagine that at a certain time when people were traveling by horses and so on across the United States, how did they imagine how long the journey would take? How did they plan for it, right? They had to come up with certain estimates which look like this. And of course, they didn't have Google and other kinds of things. So also doing a little bit of historical time travel and imagining people figuring out all these things for the first time could be quite interesting too. Okay, so we got the width of the United States. Now we run into something very important. I've kept it kind of behind the scenes, but we run into something extremely important that's usually stressed in physics classes in the first few chapters, and everyone typically goes to sleep on it because it's not very exciting, is that whenever we want to talk about anything concrete, we have to pick units. And there's a whole lecture I can give to you about the beauty of units, but we need units, right? And so, of course, here, the natural unit for measuring speed is in miles per hour. But when you're going to walk, maybe it's easier to ask, how many feet. So switching between miles and feet make it easier for us. Okay. So, so what do we do here? You just convert this into feet. That's a number that is hard for you to reason about, but it may be nice to know that it's about 5,000 feet in a mile. It may be interesting for various ways. Again, you can see if you can estimate that number. The best way to estimate that number is to think of a track and use a distance that you understand. If somebody has been on a track or run a track race or something, then you could probably figure your way around it, okay? So once you got the distance, the width of the US in feet, now all you have to ask is how big is a step that I take? How many feet is one step that I take? And again, I used a reasonable number here, 2.5 feet is one step. You can tweak it for your own dimensions. And then I just have to ask how many steps will it take for me to cross the US? So I take the size of the US in feet. I divide by the size of my step in feet. Notice I use the same units. And then I got the number of steps I need to do. So that's the task I need to achieve. I need to take this many steps. I could program it into my Fitbit step counter or whatever. And then instead of 10,000 steps a day, I could think of it as a fraction of my walk across the country, okay? But now I can convert this into days. So it's in feet, I've divided it, I know how many steps. Now I need to convert it into days. So now I need a model for how many steps will I take in a day. And this model, I use the same similar model that I used last time. I said, I'll take one step every second. It's a model. I take 10,000 steps every day. That's another model, right? So you can use different models. And then all you have to do is count how many steps you take for the day and just divide the total by that. It'll give you the number of days. Okay? And of course, in this assumption, I said one step every second. I assumed that I was walking 24 hours a day, which is unrealistic. So I should cut it back down to maybe I walk for 8 hours and sleep for 8 hours. So you can adjust that parameter as well, and then compute the actual time it takes. Okay, now I have actually checked on the web. I thought here's a list. So if you go to this web page, you can see there's a bunch of people who actually walked across the US, and you can actually see how many days. Wikipedia is a great resource. I'm sure all of you use it multiple times a day. But if you go to this, I've given the link on the website. If you go to this web page, you can look up this particular topic. Okay, so so now you can go back and revise your original guess. Okay, once you've done this, you can revise your original guess. Again, I'm going to wind up this particular exercise right now. I want to tell all of you, please delete this code, change the model, create your own model, and work it out. Okay, and it starts to build up a scaffolding. Now, at this moment, I also want to pause and tell you, a typical Python course would simply say there's multiplication, addition, division, subtraction. I'm taking you one step further and saying, as soon as you get some programming tools, we must use them to solve some interesting problems. And to solve interesting problems, it is not enough to know that addition, multiplication, division, subtraction exists. Right? We need a way to build a model, decompose the problem, break it into small steps, store intermediate values in various places, and then assemble it all to solve the problem. Okay? So hopefully you found this an interesting example. Let me just spread. Yeah.
I'll just pause for a second. Just wanted to get a feedback. Do you think like it's right now, it's very simple, we should just increase the complexity, go faster over these?
That's
because it's Python for beginners. So we assume that we have zero knowledge of computers. And that's why the first session is very basic. But just wanted to take any questions. Anyone has any problem with writing the code or following through? And again, you're saying, don't be afraid about asking questions. This is a live classroom. Otherwise, you could take a course on Coursera or EDX. There are like many online Python courses. This is a live course. Please ask questions and give your feedback.
Yes. Please send me, just type me your comments back in chat right away, right? Just talk. We are both, Manish and I are both aware that I'm going slowly. And for some of you, this may be easy. But please let me know and we can speed up things or whatever. What is important here though, let me just now stress why did I do this? And the first $1 million question, $1 million skill that I want all of you to acquire is how can I ask interesting questions? Right? If I give you a calculator and say, okay, go find something interesting to do, that's hard to do, right? What do I do next? And I'm giving you an example. I just made up a question. How can I walk across the country? Okay, then I solve it, right? That question is hard to ask, right? After that, you can build up the answers is the next part, right? So in your life, I've given this particular comment to students. I'm not sure all of you will get it the first time. It was a revelation to me as a physicist as I made my progression through my career. The first half of your career, you spend your time looking for answers. The second half of your career, you spend looking for questions. What startup should I create? What problem should I solve? What product should I create? What code should I write, right? Those are hard questions, right? Because you're not looking for an answer now. But if we can come up with good questions, it opens the door. That opens the door to creativity, right? I think there's a quote that says, computers are useless. They only give us answers. Humans have to come up with the questions, right? So I want to put that as a shocking thing to you, that our educational system does not force us all the time to ask questions. Here today, I'm asking you, start creating lots of questions to yourself, and then you can share it with people, right? Then once you create the question, I want to share with you some things about which will be very important as career tips for you. As soon as questions emerge, we can be uncomfortable with not knowing, because you ask difficult questions and it's very uncomfortable. I want all of you to get comfortable with not knowing the answer. It's okay, right? In fact, in this course, I will never chastise anyone or criticize anyone for not knowing the answer. It's okay. We can always find it. Once we know the question, we can always find the answer. So it's okay. But then the next thing we must do is make sure that we refine the question and make the question precise. When questions are not precise, it's very hard to find the answers. And then the last thing is to be eager, willing, to brainstorm, to be creative, to partner with people. That's just the way to find all the answers. Okay, so if you can do these things, you will be tremendously successful. And so if you have any inhibitions with questions in the past, or you're not doing enough of that, start developing that skill aggressively, right? And I gave this example, like if you go, all of you will be going to interviews and various things. If you go to an interview and somebody says, how tall is a building? I'm in this Google headquarters XYZ or whatever, some XYZ company, I'm in the headquarters. How tall is this building? If somebody asks you the question, you did your research and you memorized the height of this building, it's easy for you to blurt out an answer. But if one candidate said, no, I can calculate it, and I calculated, I give you some example here in this, you can read it. I calculated using some model. Clearly, that candidate is going to be more interesting to the employer, right? So developing the skill will be absolutely valuable for you right away and very soon as you are working with others and looking for job opportunities and so on. Okay, so there is one more. Okay, this is a very short one. Of course, you can ask the question. It's just a calculator. You could use a handheld calculator. Somebody once asked me this question, so I put this in here. You can read this in detail, but obviously, I'm sure all of you understand. This is just the tip of a very big iceberg. We can do amazingly powerful calculations with this calculator that no calculator can easily do. And of course, all of this can be automated, so the jobs can be run without humans in the picture, etc. Right? So it's not even a serious discussion. The calculator will never compete with a computer. Okay, then okay, so again, you can post me this in chat. Order of operations. How many of you remember this concept? Some of you do, or maybe all of you do. I just want to stress something very interesting though. This concept is introduced in a mathematical textbook at some point in your math career. But I want to tell you that this is a general idea in computer science though. When you have multiple operations, we always have to decide which operation has to be performed first, right? So it's not just an arithmetic question, because arithmetic has formalized it in a certain way. When there's a part of programming in which you create your own operations, right? And we'll see that later. When you create your own operations, it always constantly asks this question about precedence. Which one has to be evaluated first? So as soon as you have more than one operation, this question is emergent. So it's not just a tedious math, PEMDAS or BODMAS. I'm not sure. Some of you can type, how do you remember your order of operations? I think it's different in different countries. Does anybody know, if I asked you to give me the order of operations for multiplication, division, addition, subtraction, yeah, okay, Praveen says BODMAS. Yeah, so that's an Indian, certain English system says BODMAS. The American system says, does somebody want to say another acronym? Yeah, PEMDAS, there you go. So there's BODMAS and PEMDAS. So the B and the P, B for brackets or P for parentheses, okay? E for exponent, so I've written it here. So this is the acronym. I use the PEMDAS one. So let me just stress this. So parenthesis is really important. So the concept here is interesting. Whenever you come up with order of operations, you need one particular operator that gets the most power, that is evaluated first. Because you want to override the normal rules. You want to change the normal rules, you use parentheses. Okay, so parenthesis is really important in any ordering convention. There will be one operator that wins everything. Okay, and that's the parenthesis in the example. Then you have the exponentials, multiplication, division, addition, subtraction. Okay, it looks like this, but I have to ask this question and stress this question. and I've done this in my chart, multiplication and division have the same order of precedence. So then how do we decide? If I have multiplication and division, which one should we do first? Anyone want to tell on chat? How do we decide which one goes first? Left to right, exactly. We use our reading conventions, right? So left to right has to be used in that case. I stress this here because remember, it's a structural thing. Of course, since I did multiple operators, I have to tell you what to do, okay? So again, spend a little time. I don't want to spend too much time on this. Spend a little time writing some expressions, using the parentheses. I've given you one question in the quiz for you to just do it. So just go ahead and do it, okay? Can you give me some quick feedback in chat about the code editor? You guys are all able to write some Python code. Any problems? Is it fun? Is it easy? Easy to use. Okay, Mitch says easy. Yeah. Christian says all good. Okay. Excellent. Thank you. Yes, your inputs are helpful. Okay. So yeah, like I said, as we go through this course, I will show you other editors and other ways to use Python. For right now, it's going to be very easy for us to write code. So you don't have to worry about anything. Just start typing and off you go. Okay. Okay. So now so we learned about variables. We learned about mathematical expressions. We learned about solving problems and asking questions. We learned about order of operations. And now one last concept, which is important, is this is a slightly abstract concept, but probably foundational, is the question, what is a type and why are types used in programming languages? Okay. And I am absolutely fascinated by this structure called a type. Okay. And I would tell you that when you study mathematics, it will take some time before, for example, let me give a simpler question. If you ask a question, what is a number? And if you explore that question deeply, you will realize that it is a deep question. Because a number is not a symbol. It's not just a symbol. So if I write the number 2 and I have a symbol for it, is that symbol the number, or is there some other concept behind a number? Right? And by the time you get to defining what is actually a number, you would have learned a lot of things. So similarly, there's an abstract idea here in programming, which is everything is built out of this notion called types. So we have to start by asking the question, what is a type? If this is abstract, it's okay. It's the first time you see it, just keep it in the back of your mind. I will give you some very concrete things to work with in the next tab already, okay? So the idea is this. When a thing has a type, we are saying that it belongs to, it can be part of a collection, and all elements of that collection have the same properties and behavior as the object that I'm looking at. So if I take the integer 5 and I say it has the type of an integer, it means that it belongs to the set of all integers, the collection of all integers, and all integers have some common properties and some common behaviors. For example, I can add 2 integers together. Okay, so the type is an abstract idea, but of course now it becomes very concrete. Okay, now why am I stressing this idea so much? I'm stressing this idea so much because as soon as you recognize the type of a thing, you know what you can do with it. You know how you can use it. So the type is very powerful. And if you do the wrong operation on a type, it will break your program. So all programs can be thought of as building something by joining types together. Types are like Lego blocks in your program. If you find the types and connect them together, your program will get written. Sometimes you will recognize that a type doesn't exist, that you need this kind of type and it doesn't exist. Then you will create your own type and use it in a program. Right? So the entire task of programming is all about creating, recognizing, and using types. Okay, so a very powerful statement that I've made. Then you can parse it, think about it, etc. Okay. So now that abstract statement becomes very concrete. So we have to ask, okay, I'm going to start writing Python code. What types am I going to use? So let me just introduce you to a few what are called basic types in Python. Obviously, there's the basic type called integer. But the integers are not written as integer in Python. It's int. Okay. And then real numbers. The type in Python is called float. Then there are booleans. We'll spend a little time on booleans later, but booleans are basically types that can take values true and false. And so it's represented as bool. And we'll talk about strings in a moment, okay? So I have given you three different kinds of types. Obviously, they're distinct, right? You can recognize them as soon as you see them. And the important thing in Python, which I want to highlight is, even though I stress types, Python actually says something very interesting. See, I have declared a variable here, not a very imaginative name. I've declared a variable. Now, the first thing in Python is you can basically ask Python, what is the type of this variable, right? So there's a command here which will, at least initially, you could probably find it useful. There's a command here where you can basically take any variable and you can ask Python, what is the type of this variable? So now I'm going to show you something very interesting. If you run this, it tells me that the type of the variable is integer, as I promised you, right? Now, this is a big distinction from Python to, say, Java or C. What is the distinction? In C or Java, you have to make declarations of what is the variable going to be. On the left-hand side, you have to say this variable has to be an integer. So the variables have types on them. In Python, variables don't have types on them. Then when I asked for the type of this variable, how did it get a type? It got a type because on the right-hand side of the equality, there is an expression. That expression has a type, and the variable automatically picks up that type of the expression, right? And that's called dynamic typing. So it's a deep idea, very cool idea. So if anyone suggests to you that there are no types in Python, it's not true. As I just showed you, when I asked Python what's the type of this variable, it tells me it's an integer. But the type can change. And how do I change the type of this variable? By saying, for example, if I give it a floating point number, and if I run it, now the type will change automatically. Okay, so it becomes a float. Okay, so this is something you have to get used to. Later, we can debate, and we should debate, is dynamic typing better than static typing? Okay, it's a big debate. It's one I'm very passionately engaged in. And there are some attempts now to kind of bring certain types of type ideas into variables in Python in the future. But for now, it's actually, a lot of people love it because they say, I can start typing. I don't have to think about what is the type of the variable. I just start typing, right? Python will figure it out. Now you might say, oh, I could know it, but you can understand why this is interesting, because if I had typed an expression, a long expression, which actually became a floating point number once I evaluated it, then Python will figure out the type correctly. I don't have to do the work. Okay, so you can use this capability effectively. 3 types for you to learn today. We'll start building programs using these types. There's one more type I have to introduce. Again, I have a whole section dedicated to this type. It's called the string, but I want to give you the strings early just so you can get started. Okay, and how do we, so the first question with any type that we have to ask is, how do we create the type? Okay, and for the basic types that I gave you, there was not any work to be done. You just had to type it and you were good to go. But if you want to create a string, there is a special incantation you have to do. And the reason is that the string has many characters in it. And as soon as you have an object that has many components in it, there's a special activity you have to do. For the string, the special activity is to use quotes. So you can use the quotes and you can create. So now this has become a string. And if I run my code again, you'll see that the type of this variable is of class str. And str is the Python type for string. Okay. So you can create strings. Why did I introduce strings here in a little bit of a quick way? Is because we will need strings all over the place as we start writing programs even today to display information to yourself when you use your print statements. So the important idea is you make a string and you can add them together like this. You can join them. So very interesting. As I said to you, as soon as you have a type, you can ask what kind of operations can I do on a type. So if you have a string, the operation that you can do on a string is to concatenate or join them together. And that operation is represented as the plus operator. Very interesting idea, right? That we said for integers, plus means addition. For strings, plus means concatenation. So when you want to build up a message, you can always join strings together like this. Okay, so again, take some time. Just write some code. Don't worry about the code that I've put in here. You can write your own code. Just create a few strings. I have to share with you one last idea. There's a special kind of thing that you use in your program, which are called comments. So you put a hash symbol, and then you can write stuff, and Python will just ignore it. So if you want to explain something to yourself, you can just put a hash symbol somewhere in your code, and you can type, this is a test, right? And Python will just ignore that. So comments are good for you to leave information to yourself. I will use it once in a way to share some information to you. And just one last tip, if you can take it, if you use this thing, which is 3 quotes, it actually creates what is called a multi-line string. And I show you this 3 quotes thing only because if you want Python to ignore a part of your code, you can quickly put 3 triple quotes around it. Okay, so I've actually mentioned it here, so you can read it up. Just use the triple quote, and you should be able to hide code if you need to comment out. We call it comment it out. It's like becoming a comment here. Okay. Okay. So one last idea, and then we can wind up this session, I think, is okay. Now that you have types, there'll be many situations in which you need to convert from one type to another. Okay. So for example, let me. Okay. So I have to give you one. So to build programs, I need building blocks. So I'm going to use, we used print already. I'm going to use one more function, okay? So this function is called input. So input basically takes a string. It displays whatever this string is, it displays it to the user. And then when the user enters a value, it gets that value and stores it in this variable called number. I could have called this variable anything. So I'm going to ask the user, can you please enter a number? So this function is very useful because it makes us to write interactive programs. So already on day 1, you can say I started to write interactive programs. Okay, so it will print out the string, the user will enter a number. Then I can do anything I want in my program with the number that the user has entered. Okay, so for example, if I run this program, so what I'm going to do is I'm going to get a number from a user, and then I'm going to multiply that number by 3. Okay, so let me run it. So enter a number, let me pick a number, I don't know, 2, and then I run. And I got 2, 2, 2. So now that's a puzzle. And as I said, it's easy to cause bugs in programs, and half of our job and half of my job as an instructor is to get all of you comfortable with bugs. Okay, broken programs are good. This one doesn't even have an error on it. So it's a very dangerous bug because it doesn't break anything. But it just doesn't do what I expected. Because I expected to get the number 6 as the answer, but I got 222. So does anyone want to tell me on chat, how did this happen? Or chat, or you can unmute your microphone and tell if it's longer. Yeah, somebody said it's a string. What is a string? The input is a string. There you go. That's the right clue, right? So I think I went over it quickly. Well done. Well done. So more of you might have got it, at least for the 2 who shared on chat. That's the right clue. The input function actually returns a string. So what happened in this problem is input gave me a string, and I ended up multiplying a string by 3. So now we have to ask the question, what happens when you do multiply on a string? And in Python, when you multiply a string with a number, it just like addition joins strings together, multiply replicates the string that many times. So because I multiplied the string 2 with the number 3, 2 got replicated 3 times. Okay, and this is a beautiful example or a simple example of how we got our types wrong. Right, a wrong type flowed through my program and broke my program. Right, so and you can see how severe this problem is because the program was very big. We may not have found it so easily. And so you have to trace your way back through the program and find out where did I get the wrong type. Okay, and once you find this problem, programmer's tip, of course, fix the problem as close to the source as possible. So as soon as you get the input and you intend it to be a number, you convert it to an integer. Okay. Okay, but if you convert it to an integer, do you think we're done? Should I break it, or can I ask? If I run this, will it work? Anyone says yes, anyone says no. Can you type in chat? Do you think this program is fixed now? Praveen guesses yes. Some people guess it'll work. Okay, so we're almost there. Yeah, somebody got the type error and put it in. Exactly. So if I run it, yes. Okay, so let's enter a number. I will enter the same number we did before, which was 3, I guess. Oh, sorry, it was 2. But anyway, yeah, you see there's a type error here. And what's the problem? I wanted an integer, I got an integer, but now I'm trying to add an integer to a string right here. And I can't really add, number is not a string. I cannot add it to a string anymore. Okay, so this int that I used is a type converter or a type constructor. It takes a string and makes it into an integer. I need another type constructor here which takes an integer and makes it into a string. Right, and if I do this, this will work, but I will get an error somewhere else, maybe. I get an error here because this is again an integer and I need a string if I'm going to do plus, okay? So then again, I got to put the str here and then my program will work. So this was just a toy program, easy for us to find errors and fix, but it's a metaphor for how important understanding our types are and how important it is for us to think about our program in terms of the flow of types and the interaction of types. Okay, hopefully this little program gave us a sense of how important that is. Okay, so I tend to be very type-centric in my thinking. Each of you should develop your own style, but I would suggest that it's very important. And on day one, it's a good way for me to introduce you to. We learned 4 different kinds of types today, and now you can start using them to write your program. I think that's mostly what I wanted to cover. Just a little piece of terminology here. The numbers that you saw today, explicit numbers like 1, 2, 3, 5, or the string called test, these are all called values. Then there are things called expressions where you combine values with operators. So 3 plus 2 is an expression. And then we saw identifiers or variables. Okay, and you understand that values have types, expressions have types, and identifiers have types. Just that it's not displayed on the screen. If you need to know them, you need to use this type function to explore them. I think that's all I put. Okay, well, since I have this on screen, as you can see, everything that I would like to cover is on the website. So when you do your practice, just go through the material, okay? Please come back to me with questions. So here I've done something interesting for you to see. I've actually embedded another Python piece of code here. This actually runs a Python session inside the browser and allows me to see what's happening inside Python. So for example, if I make this variable, if I step through this code, it shows me Python creates what's called a global frame. And in that frame, it creates the variable and gives it links it to the value 3. Right? When I run the next line, it created the variable and linked it. I put this in here to give you this mental picture that inside Python is getting built the state of my program. And right now in the state of my program, there is multiple variables which are linked, which are labels that are linked to specific values. Okay, so just a mental picture. For some reason, and I don't know if it's true of all of you, for some reason, creating and using identifiers or creating and using variables seems like not a natural thing for learners of programming. Okay, maybe my mathematical training felt very natural, but you can share with me if it feels natural or not. Okay, but using the right variables, giving them the right name, knowing what types they're going to have is very important ingredient of toolbox. So that's all I wanted to cover for the session today. I think we are at time, Manish?
Yeah, we're perfect on time.
Okay. Wow, I couldn't have timed it better.
Right, yes, exactly.
But this
you can unmute yourself for a few minutes.
Yes.
I think. Okay, so again, a couple of comments. I will reiterate. It's important. If you can keep your camera on, like Mitch has been on all the while, and you can see, I could see that he was totally into the classroom. He was fully attentive during the entire 1.5 hours. We have two very, very experienced and dedicated instructors for this course. And as Vijay mentioned, that it's very important to ask questions. We'll learn more by asking questions. So again, please ask questions. There are office hours also scheduled. If you have any extra questions and you don't think that you have time during the live sessions, you don't want to interrupt, but that's not a problem. You can interrupt. We will decide when to stop the session and answer a question, so you should not worry about that. But in addition to that, we have office hours as well to help you get started with the new IDE or new programming language or new concepts. So please take advantage of this live course. Okay. Anyone wants to?
Actually, we can open up for questions or comments.
Yes.
Conversation is good. So does anyone have any questions or comments?
Amey, you want to say something?
I think, yes. So the class went very well from my side as well.
Thank you, Amey. I look forward to a lot of feedback. I have lots to learn from you.
So I think Vijay introduced different concepts, though they sound very easy, but in a very interesting way, so that they will remain in memory for a very, very long time. And yeah, we are looking forward to more such interesting, interactive interaction with Vijay.
Thanks, Amey. Yeah. So I just want, a couple of people have posted this in chat about whether you get a drop-down window with the variables. You should get a drop-down window with variables in the screen. The only thing is that it may take a little second long because it's running on, it's running in a browser. So can you all try, once you created a variable, the editor, by the way, it's not a feature of the language. It's not a Python or an R thing. I think what people are asking a question about, if I can show you on the screen, is if I type a_ here, you see, now it's on my screen. Can all of you see my screen? If I type a_ and wait for a second, the editor knows what variables have been defined. And so it will suggest a completion. And then if I hit tab, it will complete it for me. So this is a feature of an editor. It's there in the RStudio editor. It's there in various Python editors. It's there here as well. It's just maybe too slow for you guys are fast typers. So if you're typing very quickly, I would actually, why don't you try and let me know by email or something if it's a little slow or not, okay? My screen also should lag a little bit more because it's taking video of my screen right now, but it should work otherwise, okay?
Yeah,
and
it's working. It's working.
And I would urge all of you to actually use it. In fact, I tell new programmers, please use statement, it's called statement completion or variable completion. Please use variable completion so you don't make typing errors. If you mistype a variable, it's an error, it's a bug in your program, right? So if the editor is going to complete it for you, start using tab all the time, right? And I agree with those who ask this question, because once you get used to it, you feel like one hand is cut off if it's not working, right? So if you're used to using it, you're like, oh, it's not completing, what's going on? Okay, so it will work. Just let me know if it's slow or not. So any other questions? I can let you guys go without a couple of questions or comments. And it doesn't have to be explicitly about everything we discussed today. It can be anything. Remember, I stressed the importance of asking questions.
So Vijay, one thing you can mention is in case people are using their own installation of Python, that you are using Python 3.0, there might be some people who will have Python 2.7 installed.
Yes.
And then the syntax is different.
Absolutely, Amey. So yes, I am using Python 3.0. So let's talk for a second about your own installation. So during this course, I will use different Python editors, all of them using Python 3.0. Python 3.* is what we like to call it, because Python went through an evolution where there was a big change made to the language in version 3. And it was backwards incompatible. And to the surprise of people who created Python, a major portion of the community said, we are not going to move from 2. So they kept making patches and upgrades to 2. So we are up to 2.7 *. So we continue, but they have now basically, nobody wanted to migrate to 3. But anyway, that's been a 5-year-long process, and now eventually we have more and more people on the 3.star versions. So it's one of those very heavily debated questions, even something I'd spent the time whenever I start a class asking whether I teach on 2.star or 3.star. By 3.star, I mean, like, for example, right now it's Python 3.6 is available, even 3.7 is available. Right? So there's an evolution of the language that is quite interesting. If you want, especially 3.7 has some very interesting features in there. So if you guys are interested, I'm happy to share. But for this course, we will use the 3.star sequence of, and 3.6 is probably a good place to start. Somewhere around 3/4 of the course, when we are 3/4 into the course, I can actually talk you through installing Python on your own computers. Okay, but till in the beginning, I would rather you spend time thinking about the language, solving problems, writing code, etc., rather than trying to install stuff. And many of you have different kinds of machines, so things can break and so on. You might have old installs of Python. If you're on a Mac, there's a pre-built install of Python on the Mac machines, etc. So rather than wasting all our time on that, let's get started without that friction. Plus, I can embed everything right in here. So you will use everything that I have been using, right? So we can start working right there. But I will definitely, but can I ask, you can put it on chat or make a comment. Are you guys interested in making your own installs? You can just tell me on chat. Okay. So somewhere, yes. Okay. So somewhere in the course, I will explicitly include instructions for install, and then in an office hours, I can help you troubleshoot if any of you have trouble, etc. But along the way, I will show you how to use also Python in the cloud. This is Python in your browser, but also how to use Python in the cloud, where we log into cloud instances. These are all tools that we use today. I can give you long discussions about the pros and cons of one or the other. If you ask me close to my heart, I like everything installed on my machine and I control everything. But maybe I'm too much of an old fogey and things have changed a lot. Okay, so much for Python. And so thank you, Amay. That was useful and gave me a chance to mention these different versions and how we will handle it in our course.
Yeah. I think we are past the time. We are exceeded 11:30 class end time. Any questions? Otherwise, we'll end the session.
Okay. Just before we close, I want to say I will follow up with an email tomorrow. Just give you some logistics. We are planning to have an office hours on Monday. So I'll give you the logistics for that. We'll do a session just like this. Can some of you just text me? Would you find office hours interesting? You have to come with questions though. I'm not going to dump a lot of material. I can discuss any questions you have. But can some of you say, how many of you would be there on Monday for office hours?
Probably session 1 is too simple. Probably not many people.
Okay, so I want to tell all of you that please start developing something that I value a lot. Is you have to drive yourself towards your learning goals. Okay, please. I will do my best to push and show direction. I will lay out the curriculum. I will drive you in certain directions. But it's just as powerful when you start saying, I would like to know more about this. I would like to install Python on my computer. I would like to, try to move yourself forward towards your learning goals. Okay, please, being passive is probably the worst thing you can do for yourself. Okay, and I'm not here to criticize anyone or challenge anyone. There are no bad questions. So please engage me. And if the public forums are difficult or you find it hard to ask questions in a group or something, send me email. I'm also quite willing to schedule one-on-one time with you if needed. Okay, but with that said, I want to thank all of you. Hopefully you had fun. A slow session, but lots of stuff for you to think about. And please make sure you have those 3 hours. We're going to build a habit of spending 1 to 3 hours every week typing some code and thinking about programming, etc. So don't be restricted. Don't say the course material is too easy. You can always go ahead, right? There's many things that you can do. So please make sure that that 3 hour window is a good habit for all of you. So thank you all of you. And I look forward to meeting some of you on Monday, all of you on Monday, and then we'll talk again next Friday. Amay, thanks a lot. It's such a pleasure to have you with us. And Manish, thanks as well.
Thank you. Thank you, Amay. Thank you, Vijay.
Thank you, everyone. Thank you, Manish.